if you want, I'll write omega, no problem. With a constant angular velocity, they'll be rotating. On that, a Planck is placed and it's in equilibrium. Now the Planck is slightly displaced. You have to calculate the time period of oscillations of it. Find the time period of oscillation of the Planck when it is slightly displaced horizontally and released. Okay, these two are fixed. The cylinders are rotating about a fixed horizontal axis with constant angular velocity. And the surface between the Planck and cylinders are rough. Okay, very, very fast, try to displace it. So initially, so there'll be normal contact between them. And what about that normal contact? The normal contact will be equal. Okay, how the friction will be acting? Friction on the Planck like this. Friction on the cylinders will be in this direction. And let L be the length between centers of C1 and C2. Then the weight mg is acting. Okay, there's the initial part of the diagram. I'm going to slightly displace it. Then we are going to see what conditions will arise. This is L. In what direction? Any direction? Okay, let me slightly displace it. You can see now. Slightly I displaced it. Are you able to? It is being displaced. So now what will be the normal reaction? We have to check it now. Normal reaction, it is on the Planck. It is. We are not bothered on the cylinder. It is on the Planck. N2, call this N1. Center of mass will get displaced, no? This you write C. So initially it'll be at a distance L by 2. Now the center of mass also will get displaced. So here, what is the distance? This will be L by 2 plus X. L by 2 minus X. What do you expect normal contact as? It will be different. Okay, let me call this is N2. Anything, the right hand side N1, this is. The frictions will be F2. Anybody, why friction will change? First of all, why normal contact will change? So initially that 2n should be equal to mg. 2n should be equal to mg. Then which will be greater? So as I shift the Planck towards right, I think N1 will become greater than N2 because the center of mass has come here. So net torque on this should be 0, no? It will be only oscillating like this. We have to calculate the time period of oscillation of this one. So So in what direction there'll be acceleration of center of mass, the acceleration of center of mass. So what is first, I'll directly start away with this equation. FA equal to MA equal to F1 minus F2. I had to calculate F1 and F2. What is F1? In turn, this is equal to mu N1 minus mu N2. Okay, there's the initial beginning part. So let's come for this one. Net torque on cylinder should be 0. Net torque on plank must be 0. So all will set up torque N1 into L by 2 minus X, N2 into and in turn N1 plus N2 minus mg equal to 0. Okay, so this will be, let's write it here, no? So N1 plus N2 L by 2 should be equal to N1 plus N2 into X. What is N1 plus N2? I'll substitute this equation. So N1 plus N2 N1 minus N2, no? It is N1 minus N2. Okay. So I do have two equations. So this is the equation 1, 2. Okay, so we'll start from here. There's a 1, there's a 2. I'll bring later on this. We'll write it separately here. Solving this, we ended up with this equation. I'll put everything in order so that it'll be easy for you to follow up. Solving this, net torque equal to 0. So finally what will happen? And N1 plus M2 equal to 0. So we ended up this equation. So there's the equation 1, you write it. There's a 2. Then put one into. So call this equation 3. Solving 1 and 3. I'll get N1 and N2. Call it as equation 3. Solve 1 and 3. We'll get N1 and N2. Then we'll enter, we'll substitute here. We'll show that acceleration proportional to negative of displacement. So solving.
So directly we can substitute, sir, N1 minus N2. MA equal to mu times of N.
Yeah, fine, no. Okay, I didn't check it. So mu into. So this A is equal to 2 mu G by L into X. So this acceleration will be proportional to negative of displacement. We can do directly, no? Okay, thank you. Yeah. I was thinking some other way. So the time period will be 2 pi L by 2 mu G. Very simple. Something related to torque idea. How the motion of plank, the cylinders will continuously they rotate constant angular velocity. The plank will be executing SHM. From where the restoring force will come, this N1, if it was displaced towards right, N1 will increase, then F1 will increase, then F1 minus F2 will be restoring force. So it will bring the back, it will bring the plank towards left here. So like that, the plank will be executing SHM. The cylinder positions will not change. This is very important. The cylinders where they are, they're there only. C1, C2 are fixed. Once again, I'll write it here. Please do make some observations, which are very essential. Okay, we'll wind up the class. Yeah, this will be our answer. Few more problems are there. I'll just leave it. Try to work out them. Tomorrow I'll continue from the problems which were left over. Okay, thank you all of you. Yeah.
Thank
So
you,
try
sir.
to